All right, everybody, Bass Action is back in action here. We are going to look today at betweenness and applying betweenness to some problems to incorporate with our algebra. So the two things that you're going to need out today, you are going to need your Chapter 1 and 2 vocabulary packet along with your Chapter 1 notes. All right, so on page 3 of our vocabulary packet, we're going to be focusing at the bottom here, vocabulary word number 16, betweenness. So what we can see with our definition here of betweenness is it says that if A is between B and C, then A, B, and C are collinear. Now, this word here, collinear, is a crucial word for us in our definition. We need to keep that in mind. So the first thing we want to do is we want to practice just what does the word, when we use this word between, what does this mean in terms of a picture? So since it needs to be collinear, we're going to put 3 points on our line that it's provided here for us. And when we put these 3 points on the line, we're going to spread them out. We don't want the one that looks like it's in the middle to actually look like it's in the center. So we could say for this problem, we could say A is between B and C, because we can see that, in fact, this A is right here, and it's between, and it is collinear. Now, if we wanted to draw a counterexample for this, all that we would need to do is to take any one of those points and move it off of the line so that they're not actually collinear. So for example, I could put the B up here and then put my A and my C here. Doesn't matter which one I move off the line, we just want to indicate that they are not collinear. That's our simplest counterexample. All right, moving on to the next page, the word between comes into play when we start to look at what's called the segment addition postulate. Conceptually, the segment addition postulate is just what it sounds like. We're going to add segments. When we're going to find these problems through a phrase that sounds very much like what we just saw on the previous page, where it's going to tell us that a point is between two other points. So this sentence is the same as what we had before. B is between A and C, and means we can add some segments together. So we're going to look at another one. We're going to go over here to the far right where it says O is between B and G. And if you look at my picture here, that's exactly what I've provided for you. I have my O. I can see that B, O, and G are collinear, and my O is between my B and my G. Now, following the idea and just thinking of the name segment addition, that's exactly what we're going to do. We're going to be able to look at this and we're going to be able to say that this part plus this part is going to equal our whole segment. Okay, so if you just think of that in as you're working through segment addition, so we can now write that and say BO plus OG equals BG. Don't worry about the reason for right now, I'll come back to that later, but I do want to call your attention to the fact that I did not put the bar over any of my segment names because I was using the equality on these, so we don't want to use the bar over our segment names in our notation here. All right, so now let's go. All right, on this page, what we're going to do is we're going to take our idea of betweenness and that segment addition, and we're going to extend it a little bit more and incorporate some algebra into this. So what we're going to do first is we're going to look at our two examples here, and we're going to notice that on each of our examples, we have this keyword here of between, okay? So we're going to draw our picture first. So just like we did on the previous page, except for now we have to start it, and we've got two endpoints and a point that's somewhere between. Remember, we like to scooch those to one side or the other. So on our first one, we're going to have our H is going to be between our C and our I, and our second one, we're going to have U is going to be between our H and our B. Now from there, what we can do is we can actually label whatever information they give us about it. So for example, it tells us on the first example that CH is 7x plus 13. And it tells us HI is 5x minus 1. And it tells us that CI is 3x plus 84. On our second example, we're just going to read through our parts. HU says it's 3x plus 4. HB, notice it went in a different order this time. This time it gave me the whole segment next, so it's going to be 5x minus 8, and it tells me that UB is 42. All right, the next thing that we want to do is we want to think back to that geometric statement, that little equation that we wrote with segment names on the previous page when we were working in our vocab book. So what we can say geometrically on this is that CH, on example 1, CH plus HI, remember we're just thinking part plus part, is going to equal the whole segment of CI. And then on our example 2, again, part plus part equals the whole. We're going to say HU plus UB equals its whole of HB. And once we have those, what we call geometric statements, we can just substitute looking at our picture. So it tells us that CH from our picture, we can just read it straight from there and substitute, is 7x plus 13. From our picture, we can see that HI is 5x minus 1. And our whole segment CI is 3x plus 84. So solving this algebra, we're going to have our 12x plus our 12, collecting our like terms, and our 3x plus 84. Moving all of our x's to one side, we're going to have our 9x. Moving our 12 to the other side, we're going to have 72. So we're going to get an x equals 8. Now, this is an important part to pause and to go ahead and take a look up here at the original problem and take a look, what did it ask you to solve for? Only after you've taken a look at what you're asked to solve for do you know whether or not you're done. It said solve for x. We've solved for x, so we're in fact done on this problem. So let's go ahead and look at example 2. We're going to substitute again. It says HU is 3x plus 4. It says UB from our picture is 42, and HB from our picture is 5x minus 8. Again, let's just collect our like terms. We're going to have 3x plus 46 equals 5x minus 8. I'm going to move my x's over to the right. I'm going to get a 2x. I'm going to move my 8 over to the left. I'm going to get a 54. So x is 27. Again, let's go ahead and take a look. What does it ask us to find? It asks us on this problem to find HU, meaning it wants us to use this value of x to actually find the length of segment HU. So we can take our value for x and we can just substitute. So we're going to say HU, I'm going to switch that to a red there, sorry about that. So HU is equal to 3 times the 27 that we found for x plus our 4. You can either do this mentally or you can poke this one into a calculator and you'll get 85. And we can put a U on this for units because we don't know if our segment is measured in inches, feet, miles, or whatever. So we'll put a U for units. So that's all that I've got there. Don't forget that it might be a little bit easier if you subscribe to this YouTube page so that you don't have to look for it each and every time. All right, we will explore this a little bit more when you see you in class.